Hi, folks. This is Wang Bulao Banda. Today, I'm going to explain Fermions, electron holes, with Chinese philosophy, Yin and Yang. So the title is like my discussion, my mythical discussion about the semiconductors. The purpose is to make this hardcore science somewhat interesting. And so please indulge me for exploring this aspect. And I really hope that you could get some very interesting aspect of semiconductors using different kind of philosophy, different kind of approach, and to enhance your learning. Of course, the first thing I would do is to ask AI about this. My top choice AI is Perplexity. I asked AI to explain fermions with yin and yang. All right. So that is my question, and the answer is this: please use yin and yang theory to explain the electron holes in a semiconductor. Well, they replied, somewhat interesting. Let's look at it. The concept is analog to the yin and yang duality. All right. See, it says that it can be used to explain. Electrons are associated with yin, representing the negative charge, and holes are associated with yang, representing the absence of electron or positive charge. I have a different opinion, but that's what the AI gave me. But it's interesting, right? So the pair is yin and yang pair, and electron and hole pair. Okay, they are opposite and interconnected and influence each other's behavior. So that make it relevant. So yin and yang does make it relevant, all right? So that part AI seemed to go along with my approach. And here is a symbol of Chinese yin and yang. It's a circle with black and white portion, and in the black and white portion individually, there's a white spot and the dark spot. Actually, according to the book of Tai Chi, which is a theory to explain yin and yang, is that actually it explains the whole nature. Okay, the whole nature. And I want to translate this word into English, and then let you see what's going on. It says in Chinese, 前道成男，坤道成女. And let's see what AI tells me. All right. So we're done with this. Let's go with this one. So what does that mean? In Taoist philosophy, this phrase, 前道成男，坤道成女, means that Chen represent the male and Kun represent the female. The two interact with each other and give birth to all things. The key message is that all things are constantly changing and growing, right? And this is what the Tai Chi is about. Everything you see, this is a dynamic equilibrium, all right, for the nature force. Yin and yang, you could treat it as a mutually existed, but mutually influenced. And the both of them formed by the circle is enclosed in this circle, all right? And so with this duality theory, we explain the heaven and earth. Tiandi means heaven and earth, sun and moon, daytime and nighttime, summer and winter, movement and then the stillness, the strong and the weak and tender. It always tries to explain how nature works, including human behavior, with this kind of duality theory, that they co-independent and coexist. All right. So this boundary is never a clear. You could think of it as a dynamic one. Well, And this is how Chinese observe the nature. For example, let's give an example for this. Let's look at the solar, the sun surface. This is actually the sunspot as we know it. So this is sun with extremely high temperature, but has some kind of a sunspot, like dark spot here. This just because it has a lower temperature. So it appeared to be that way. It still has very high temperature, by the way, but it coexists in the sun with the sun. And as part of the sun, and if I use the Chinese use if I use the yin and yang theory to explain this, you can see that the white portion, if we say this is the extreme yang, extremely yang, extremes like the surface of the sun, and at the center, some portion because the extremity of the yang, you will give birth to yin. So the yin is embedded inside the extreme yang. So they have to coexist. And this is, Chinese 1,000 years ago observed all kinds of natural phenomena. That's the theory they come up with. All right. And you could see that it seemed to match how the sunspot visually, right? On the surface of the extreme hot sun, you see a dark spot. Well, that's what I meant, right? It's an observation. We Chinese interpreted natural phenomenon with a phenomenological model. We saw something, we try to explain it, come up with a theory, and with or without scientific base. It's just a summary of an observation. Now I'm going to say, can we apply yin yang to the study of semiconductor? Right? That's uh, that's what I'm trying to say. Why? Well, it does. Somebody did that, right? Recently, there's a interesting paper, a yin and yang model for photocatalytic reactions by Ma, who explained how this the hybrid coal catalyst, cobalt oxide, and then nitride, they could form together in a way, here like a yin yang, right, to break up the water molecule when it's shining by the sun. So we try to use the yin yang theory to explain that. So that's kind of interesting. So yeah, there are people who are trying to do the same thing with me and to explain the semiconductor phenomenon with the yin yang. Right? Let's see how mine goes with that. Right? So let's look at this. The semiconductors, right? If you look at the energy diagram, semiconductors, it has holes and electrons, and then one electron move from the valence band up and leave behind a hole, and inside this valence conduction band, it is electrons, and this reminds me of the Tai Chi diagram that I just showed on my left side here, right? Here, this it was dark spots, but it moved up, right? It moved up to here, just like the whole electron relationship. So they are somewhat similar, at least visually, right? And to Chinese, all things in nature have yin and yang, right? It's a nemesis constrained by life force. We call it hugen, means that they intertwine and then they kind of confined, but they go against each other in a dynamic equilibrium. Electron hole is the same thing, similar thing. It feels like, sorry, I use this very non-scientific words. Try to make things interesting for you, to you. And then it feels like an image is constrained by the, but it's not by the life force. It's constrained by the mass action law. All right. The mass action law is this formula. The density of electron times hole is a constant at a fixed temperature. All right, at a fixed temperature. It's controlled by the energy band gap, and that's it. It doesn't care where your formula level sits. Later we'll explain why. Okay, but that's the mass action law. So in the semiconductor world, everything is quantized. Everything is can be explained in a quantitative manner. But in a Chinese yin and yang, we could only explain this the whole phenomenon in a qualitatively qualitative, not quantitative. That is the fundamental difference. But at least visually, they are somewhat related, right? And let's keep moving. Balancing yin and yang or electron holes. You can see the energy diagram about the donor and then the donor and acceptors and how they are going on into the conduction band and valence band, and everything is still constrained. How do they constrain this? They're constrained by two things: the max action law and charge neutrality. Charge neutrality is this formula, all right? So everything has to be neutral. That's what charge neutrality means. And it has a very fundamental importance. Without charge neutrality, there's no device. Pretty much there's no device. And but how do you know there's a charge neutrality? Well, if you don't, then you have electron flow for no reason, right? And that is also an observation. That's a easily understood hypothetical Gedanken experiment. I'll explain Gedanken experiment in a later one. All right. So even if you have a complex charge distribution inside semiconductor, one in the in a valence band, one is conduction band. All right, with the donors and all this stuff inside, but it still had to obey the fundamental law, which is the mass action law and then the charge neutrality, right? So, so that's what I said. That's when I asked, does electron hole equal yin and yang? To some extent, they are, right? In the world of fermions, electron hole are codependent and mutually constrained by the mass action law. Constrained in terms of what? In terms of quantity. So if you know P, then the N can be calculated directly. That's what this formula means, right? And Chinese, on the other side, if you look at a Taiji, they seem to be balanced into one half. Maybe some missing here, right? That's at the extreme of the yang and yin come out. At the extreme of yin, there will be yang coming out. You know, like the stock market, right? You go belly up and it will come back, bounce back, something like that, right? It's a it's a phenomenon in equally dynamic equilibrium, but that's not happening in a true world of semiconductor. All right, we explain later and how exactly that means. So basically, besides charge neutrality, which is an obvious, max action law is the ultimate control in the end. Especially like these Dune, the Star Trek about this. Everything is under control, right? That's I like this sport, this one, right? So let's go back, coming back, what is the max action law? Max action law predicts the dynamic concentration of elements of life in action. Every life has a reactions. So AA plus BB equals CC plus DD. This relationship happens in every aspect of life, all right? And then, so how do we, a state the rate of a chemical reaction is directly proportional to the product of the reactant concentration values. You have the equilibrium constants. Now, this has been derived a long time ago, and it fits everything, right? Every chemical reaction, as long as it's in dynamic equilibrium, the reaction goes on forward and backward are the same eventually, then everything settles down, then the equilibrium constant can be calculated. And this constant has nothing to do with the concentration inside. It's only a function of temperature. All right. And that's exactly mimicking what we just said, right? The product of the electron hole is a function of temperature only. And here is band gap. Uh, Everything else is just function of temperature. And it doesn't tell you, say, it doesn't restrain that P has to be one half and N has to be one half. No, they could they could be in any different concentration. And let's look at how does it work, right? This is Wolfram's famous simulator, the law of mass actions. And let's take a look at what's that, right? Right. This is you go to Wolfram demonstration project. It's very interesting. Here you have a simple reaction, A plus B equals C in a dynamic equilibrium and with coefficient unity. So make it very simple. And you could play with a bar here. See, initially, the A and B, A is the red one, B is the green one, and turn to C with the blue one, right? And you could change, right? And eventually you could see this is the initial condition. If you add C in the beginning, what happened? All right. And you could change it, right? Any way you want it. And you could see the relative amount, keep that in mind, is called K equilibrium, right? And you could change the constant if you change the temperature, right? So, so these are very sensitive and very interesting. Uh, the simulation you could see visually. So when we learn something, we always want to learn something that is visual, and that help us to understand much better. Okay, so this is a good tool. I recommend you guys using it whenever possible. Wolfram is a very interesting, a very good mathematical uh, and physical chemistry in many aspects. Anything can explain by math. They have some tool. Here is ideal gas law, chemical reactions, acid-base titration, all kinds of stuff that help you to understand visually. Very good tool. So in short, law of action, the law of mass action in semiconductor physics is a product of electron and hole density. You know, it's a constant equilibrium. It unified the world of fermions with unimaginably tight control. What do I mean, unimaginably tight control then? Let's go deep before I answer that question. Let's go deeper in that. All right. This formula that is mass action law of electron and holes in a given semiconductor with a band gap Eg. Right. So, and then at a fixed temperature, all these, the other numbers here is all function of temperature and the electron mass and whole mass, and then the Planck constant, all that, quantum mechanics stuff. Let's ignore that for now. And this is what the mass action law. It basically means that it's in dynamic equilibrium, it's independent of the amount of donor, acceptor, and beauty added. So you could change P, and it will influence N as a result. That's 1 degree of freedom that we need to have in order to make semiconductor work. And without that, it doesn't work. And the precise control charge carrier is orchestrated by the charge neutrality. The sum of the N and P with a donor are fixed. it forms a basis. What I meant is that I think I mentioned that earlier here in this formula. This one, this equal to zero means charge neutrality. There's no net charge, all right? And this relationship, together with the mass action law, form the basis of a reliable performance of semiconductor devices, from transistor to ICs. These are the two fundamental laws that you have to obey in order to have a good device. Otherwise, the hell, break loose, nothing else. Let me give you what I meant that what is unimaginable tight control. All right. Let's give you an example. For N-type silicon, if I give you a dopant of 1016, then what is the concentration of electron holes? Now, this is the formula. There's this, no, not for now. Let's look at it. Wow. Oh, let's really go wow, right? It has a majority carrier concentration, right? It has a majority carrier concentration 10 to the 16. And hole, because the mass action law, 10 to the 4th, right? And what is the magnitude difference? The magnitude of hole electron against hole can be different by 12 order magnitude or higher, all right? And yin and yang cannot explain that, I'm sorry, right? Yin and yang just cannot explain. They seem to be in equal portion. Maybe some tiny differences, but they say the nature is balanced. So roughly one half, right? It's like if you don't do anything, a woman's population will be similar to a man or the men's population, about one half, right? So that's seemed to be valid while we are observing many natural phenomena. But that's not so in electrons. And that's not so in the semiconductors. And that's the beauty of it. Right? But let's go back to yin and yang. What yin and yang can do then? What yin and yang can do is that it has a book of change. It says that the world can be explained by matrix of 7 by 7 plus 1. Right? That's how book of change means. That's very interesting. Okay, let's look at it. What does that mean? Again, I'm asking. I'm asking the AI to help me out here. Say, please explain the foreign Chinese in English. Say, 大大50，天眼49，人遁其一. It means that the great way has 50, heaven's transformation has 49, and humans evade 1. What's that mean? If you go to Chinese book and try to explain this means is that the world, all nature, and they have the hidden the way to explain every aspect of natures. And in total, because the nature only 50, total 50. And then 49 is using this, you could use a matrix of 7 by 7, that's 49, to explain the 50. But there's one thing you cannot explain. There's one, you need to hide it. You should not explain. Right? And that's hidden message of change. The book of change says that you cannot go extreme. If you go extreme, something bad will happen. Right? And that actually can be translated to every aspect of life. Like you want to make money from the stock market, you should not go after the final dollar. When you win, you get out, you harvest your profit. You don't say, I want to make the last dime, squeeze the last dime out of the winning. Then you'll be in trouble. Because of what? As we said here, when you go to extreme yang, the yang, some dark spot will occur. So if you want to win the last dollar, something bad will happen to destroy what you have. All right. So that's what Chinese believe. And then if you look at the smallest unit in Tai Chi, the book to explain yin and yang, you can see that if I use the book of change, the matrix of 7 by 7 plus 1 can explain everything. All right. So in that sense, to me, is 1/50 the smallest unit. Mm, you know, from the book of change seemed that way. But if you look at the Chinese characters, how they explain the decimals, all right, and you could see they go, they're using different words to explain, and that is the that part that's probably a fundamental flaw, right? All kinds of different characters, right, to explain, you know, point 1, point 0.01, up to the big O, 10 to the minus 12. And there's no other words besides that. So we don't have any other characters when the order magnitude less than 12. Right? So this means that we could explain the difference of fundamental nature maximum 11th orders of magnitude or less. Okay. And so Tai Chi, the way I try to explain this, it stop evolving because we don't have, we lack our math symbols. This is fundamental flaw of Chinese language. We just don't have this proper symbol to explain math. So our math died a long time ago, right? It's only some, interesting invention at Abacus, something like that. So, but we try to go on with a qualitative explain about yin and yang. For example, to Chinese, a metal means all, they are all yang. They are the sun. They are not the moon, right? They are all yang and no yin. And you look at the semiconductor equivalent on metal approach, the Fermi level is very close to the surface of the valence band, all right? And then the free electrons are moving around the surface, okay? They could go to the vacuum. Here I introduce a concept called vacuum energy. We will go with that later. And this energy band gap is called the work function. Right? And then you look at the work function for all given metals. You can see that the reactive metal has a lower work function, like 4 to 4.5 roughly. And then the noble metals has about 5 values, work function value about 5. So electrons are harder to get out of the surface. This is energy required to move one electrons from the surface. And this energy usually is called, the related energy is called Shakti barrier high. And then is relative to contact to something else, to a, say, given gallium nitride example. All right, here just when you touch the metal with something changed. The energy barrier is formed. All right. For the gold, this noble metal, the energy is very high. They form a Schottky diode. And for the reactant metal, the contact with the gallium nitride, this type of semiconductor, it has a reasonably good contact. But the ohmic contact does not mean you have Schottky barrier high 0. It just means that it's a straight line for the IV curve. That's all. All right. It doesn't mean that the slope is infinity or not. So be careful. Okay. There's no metal without Schottky barrier high. And in my other talk, I explain why this is happening, because the interface screwed up. There's no perfect interface. That pretty much that's it. Right? Let's just move forward with this. Semiconductor possesses yin and yang duality to be through, we just mentioned, the charge neutrality and also the mass action law, but also through EVAC and the formula level energy. EVAC is ultimate reference. Everything you see, all if you look at a semiconductor, it has many parameters. The electron affinity, the work function, and the IE, they all relative refer to a same energy. This is called EVAC. If I want to put Chinese philosophy behind it, it's EVAC is the ultimate reference. It's the depth. All right, I think it fits all even the Western philosophy, right? Everything we do, at the end of the day, all dust go to dust, right? Or die. And that death is humans' last reference. Everybody, all mortals, will die, and we are all mortals. And this means that all key energy parameters are reference to an invisible event. You cannot see it. Let me explain what it is. And and the key message is that this magnitude cannot change. They remain the same even after contact. If they touch something else, this reference still there. You're gonna die. I mean, even you marry someone, you're gonna die. All right, at the end of the day, and that's what pretty much what it means. And EF will explain EF later. Here is EF, right? Do you think you can move around with a doping? You can move up or move down, right? You can move up and down by adding some dopants, all right? So this is not fixed, but it has very interesting properties. Here, the key message is that, so what is the EVAC? EVAC is like this mythology, the atlas of all the earth, of all the universe together. I'm not the alpha, I'm the EVAC, okay? It's underlying background energy that exists in space throughout the whole universe. It's almost a 0 joule. People calculate 10 to the minus 9 joule, okay? And then it's a 0 point energy in a quantum vacuum, right? And a system that is in a vacuum isolated from other materials. It's measured, but also can be done in a thought experiment. All right. This thought experiment will be the talk, will be my next talk. All right. It's a Denken experiment. Right. And so that's what I meant. That the EVAC is pretty much the ultimate reference. You could think of it as somebody as this god Atlas, right? The Greek god, right, holding everything above his head, or the ultimate reference, death. Okay. The Fermi level, on the other hand, what's the magic about this then? The insulator, right? And then the semiconductor, and then the conductor. They have these Fermi level in a different manner. Let's focus on this. Okay. Fermi level in a semiconductor usually reside inside the energy band gap. Can it go inside the conduction band gap? Yes, it could. In some material, it does. Right? And then by majority of semiconductor, the Fermi level is inside. Where is it? If you don't do anything, it's exactly in the middle because it has the balance. And that's what the definition of Fermi level is. It gives you the probability of an electron above or below with an equal probability. That's what it is. It's a straight line. It's a description of the probability of one half. That everything above and below is one half for a fermion to exist. That's what it means. But for a metal, well, there's no energy band gap. Okay, and then so inside this is the exactly portion that the Fermi level is inside the surface of a metal in the valence band. Okay, and does yin and yang have the same control? Can we control that? Well, sorry, you cannot. All right, as I explained, the yin and yang, even there's a border here, right? Fermi level is here in the middle if it's no dopant, right? Everything is one half, pretty much. And then here, n is equal to p. And and it seemed to match, the yin and yang seem to match in a way that yin and yang balance. So this is intrinsic nature of how nature works from the Chinese yin and yang perspective. It does not, you cannot alter this. All right, that's what Chinese believe. You cannot alter this line. You always one have, and then you always have this special duality phenomenon, but you cannot change the line. Say, I want a very small yin and very large yin. It doesn't work that way. Everything has to be balanced, almost to exact one half, right? Then the metal, on the other hand, is full of yin. And what it does, because there's no yin. And the concentration on that sense is that the electron density of metal is closer to atomic density. It's very, very high. Okay. And the electron hole density of semiconductor, on the other hand, is very small. See that? This density of silicon is 10 to the 10th, germanium is 10 to the 13 centimeter cube. Okay. And that's the intrinsic when you have no dopant, let's go intrinsic. Electron hole density is fixed at this amount, but and you can imagine their yin and yang are balanced to some extent, right? They're all rough this number, but this density can be increased the doping to 10 to the 9 to 10 to the 21st, right? And this is the key. Without that, there's no device. The way you manipulate electron hole density through the mass action law. So in artificially, that's the beauty of semiconductor device. And metal, on the other hand, is already fixed. 10 to 12, 10 to 13 has a lot there. Is it good? Oh, yeah, to some extent, it's important because the high-k metal, okay, we need to use this property. Without this device, cannot control the VT as well. Okay? And look at these metals, all right? And their electron density is this is unit, all right? 10 to 28 is because the meter cube. So if a centimeter cube is 22, right? So this is aluminum has very highest electron density, and even higher than copper. Okay, not to mention gold. So this is very interesting. Iron, we don't use it in semiconductor. Not this. We don't use this stuff. Okay, we don't even use gold, right? And this is two interesting one we use in our silicon CMOS. And okay, let's apply that to silicon, especially silicon SiO2 interface. I said silicon is the most balanced yin and yang in terms of its system. The reason is shown in this so-called DIT, the defect density spectrum, as a function of EC to EV. You can see that inside the conduction band and valence band, there's a very low density, defect density state. And with the proper passivation is 10 to the 10th, all right? Proper passivation. So you could reach that low. But if you look at this, just adding one atom in this surface, silicon carbide and SiO2, whoops, right? And you have a big bomb, like a big bomb everywhere. Depends on what kind of crystal you have. If you have 4 hexagonals, 6 hexagonal, or 3 cube. You can see that the defect density is very high and it's uneven. And this is the reason, this is the fundamental reason why silicon carbide device is very slow. Right? And here's fundamental reason why silicon device is very fast. Because the DIT increases, your electron hole mobility decreases. So you can imagine, you can see that the DIT of silicon and SiO2 is 10 to the 10th. And then the silicon carbide is around 10 to the 12. 2 order magnitude difference. 2 order magnitude difference. And that kills the silicon carbide as a logic device. They're using for the high voltage control device, the megahertz, something like that. And here is gigahertz, right? Or higher. So you could see that the reason, fundamental behind this. And let's look at continued use yin and yang to look at even the inverter. You can look at the PMOS is actually yin and MOS is yang. Right? I treat electron as a yang, and then because hole, right? Electron hole actually has a yin. You could do the other way around, it's fine. So see, yin, PMOS, electron hole, holes as the major carrier, and MOS as the yang, because electron, right? They, if you put these two together and form in a unique manner, as shown in the right graph, you form an inverter. So it's a balance. If you look at from Chinese philosophy perspective, CMOS inverter is a balanced yin and yang silicon CMOS. So fast, large device formed by the most balanced yin and yang enabled current human technology advancements. Without this, there's no logic device. No, only silicon can do that. The other device have very hard time doing this inverter stuff. This inverter, you have the yin, you have the yang and yin, or vice versa. You have the mixture of yin and yang to enable the logic behavior, an inverter function, a NOT gate. And that's, if you view it from the Chinese philosophy yin and yang, it has to be balanced. Intrinsically, they are not exactly balanced. We know the whole mobilities is much less than the electron. You need to do some work here. But at the end of the day, if you could do it, wow, yeah, you got device, right? And then if further look at it, the inversion of a MOSFET is also an yin and yang concept. Look at this. This is a simulation of when the gate voltage in here keep moving, and then boom, just source and drain. These are source and drain. And then at a threshold voltage, what happened? Boom, it climaxed. Right? Source drain climax induced by VT. When your gate voltage is greater than threshold voltage, you have formed an inversion. Right? This is what I call inversion means. An inversion, there's 2D gas formed. Right here, 2D gas. I mean that the electron goes through without resistance, almost without resistance. They're climaxed. That's yin and yang. All right. You can think it that way. And that's a fun part. And here, I have a lady picture. It's an ancient lady who has this unique capability called yin yang. He could lock yang, which is male organ, with her yin, female organ. All right, and give you a high, and you died. Well, and let's look at what Perplexity AI talking about this. Right. This phrase that killed three, it killed more than 3 persons. All right. These government officials. All right. It says that that Xia Ji is the name of this lady, possesses mystical ability called Yin Soya. Yin Soya means that she could, using her female organ, to lock the male organ. And then the 9 noble died in her bed. All right. And that is what this means. He killing 3 husbands, 1 law, and 1 son, causing a downfall of state and the loss of 2 ministers. So that's what people, Chinese always blame the collapse of their dynasty to a women. That's what they do all the time. Horrible. All right. Horrible. But that's a legend, right? Shaji, she had this capability. So why I mention this story? Because silicon CMOS had the same problem. CMOS yin, locking yang, is called lecha. All right. When you place your device together in this manner, which is in every CMOS, right? Then in some conditions, it will form a parasitic PN-PN path. PN and PN here, it have become amplified. It amplify in a way that the leakage will become uncontrollable and lead to device breakdown. So you need to take care of this. This is given in every CMOS. And this is why you need shallow trench isolation, deep trench isolation, SOI, all kinds of stuff. Try to confine this one. So the ledger, it is, if you look at from the yin and yang theory, is yin locking the yang, right? It locked, it become an interlock and self-accelerating. PNN, NPN needs a coupling, and this coupling is naturally amplifying the signal, and it causing the device breakdown. All right. So finally, I was at the MI talk with Baron Harkonnen in Dune. He held the importance of the spice, right? He who controls the spice controls the universe. Right? The same way, the formula level, charge neutrality, mass action law, hidden spice. Okay? Who controls the space, controls the universe. I adore these figures. I'm sorry. I just love that quote. It's in my head all the time. It's really fun to talk about this in a different manner. So basically, that's what I did today. I tried to give you Fermions, the behavior with Chinese philosophy. Chinese philosophy cannot explain that much. But at the end of the day, it helps you to memorize the key fundamental laws of how electron hole behaves in a semiconductor. And I hope that's beneficial to your understanding, right? All right, up here, folks. Thank you very much.